Hello, I'm Lee Jae-won. The global AI competition is heating up daily. Today we've brought in some very special guests to discuss not only this global AI race, but also the intensifying semiconductor competition that's part of it. First, we have former Minister of SMEs and Startups, Park Young-sun, who previously headed an administrative agency and continues to show incredible passion for the semiconductor industry.
Yes, it's great to be here.
And we also have CEO Kim Nok-won, who founded the AI semiconductor startup DeepX, drawing on his core engineering experience from Silicon Valley semiconductor companies.
Hello, I'm Kim Nok-won.
What I've been most curious about is how you two first met.
When she was the Minister of SMEs and Startups, she was extremely interested in fabless companies and system semiconductors. She created programs like ARM's Compassionate Company Initiative, which was designed to help new fabless startups.
It was a project to nurture semiconductor design houses.
When you first met, it must have been a time when semiconductors in Korea really just meant memory chips from Samsung Electronics or SK Hynix. Minister Park, what motivated you to decide and advocate for supporting system semiconductors back then?
I was inaugurated as the Minister of SMEs and Startups in April 2019, and my very first declaration was, we need to get into system semiconductors. When I said that, the ministry staff had this look on their faces like, is that really our job? But in 2016, I was actually there at the match between Google's AlphaGo and Lee Sedol, right here at a hotel in Gwanghwamun. I was on site. I was deeply shocked by what I saw. That shock is what got me thinking seriously about AI back then. I thought South Korea was a memory semiconductor powerhouse and that was everything, but I realized that wasn't true. We were heading for a complete paradigm shift to AI semiconductors. With that realization as minister, I knew I had to foster these semiconductor design companies. So I initially made that offer to Samsung and SK Hynix. I proposed that we nurture design houses with Samsung and SK at the center, allowing many startup design firms to grow alongside them. But SK Hynix said from the start, we don't have the capacity, and Samsung dragged it out for 6 months before saying they couldn't do it. I was pretty angry at the time, so I made the offer to ARM, where Masayoshi Son is, and ARM responded the very next day saying they would cover all the costs themselves. I said, no, that's meaningless. Let's split it 50-50ths. And so we put in $2 million and they put in $2 million, creating a $4 million R&D budget. At that time, we provided R&D support averaging about $200K to each company. The major companies that grew from that are DeepX, Rebellions, Furiosa AI, Mobilint, and Sapion was also there. In terms of probability, it's incredible those companies are now valued at $700 million. That $200K turned into $770 million.
So back in 2016, you recognized the need for AI semiconductors much faster than others.
Back then, I was shocked, just astonished.
Kim, you mentioned you worked extensively in Silicon Valley. Could you tell us exactly where you worked and what you did?
I first encountered AI semiconductors in 2010. During my PhD at UCLA, I was at IBM TJ Watson, one of the top research labs in the world. I was visiting, and this was 2010. They asked me to build an AI processor. The request was basically, it just needs to be a few times faster than a CPU. So I started the research. After the research, I ended up creating a processor that was 100 or 200 times faster than a CPU. The term deep learning didn't even exist yet, but experiencing that, I thought, this is really going to change the world. After graduating, I joined Cisco Systems. At that time, there were about 5 billion devices connected to the internet, but Cisco was already predicting that in 10 years, the number of connected devices would exceed 50 billion, even 70 billion. Humans wouldn't be able to process that much data. What was the alternative? That's when they realized AI was necessary. And it wasn't just AI they needed, but AI chips to run the AI. From that point, I realized, this is the direction things are moving. Later, I was recruited by Apple, and around 2015, I became convinced that AI would bring about the biggest change. It didn't seem like it would stay confined to data centers. I predicted it would move into every space.
That's incredible to predict that back then.
I figured NVIDIA would do well with servers, but we needed the technology to make this low power and distribute it everywhere. That's what I conceived of 10 years ago as on-device AI. Then, in 2016, I was a development and manufacturing lead at Apple, working on the iPhone, and the first on-device NPU was integrated. It was used for the face unlocking technology. That's what pushed me out the door. I already knew everything was heading in this direction, but when Apple started moving, I thought, I should create a technology that can supply this to everyone. An open on-device AI semiconductor. Let's do this. And that's why I founded DeepX.
Park, another reason you're here is that you've recently published another book on AI semiconductors. This is already your third book on semiconductors. What made this former anchor, four-term congressman and SME minister so passionate about semiconductors?
The first person who shocked me was Chairman Lee Kun-hee. In the early 1990s, I interviewed him for about an hour. He talked about semiconductors the entire time, and I couldn't understand half the technical terms. I was so embarrassed. I thought, semiconductors, I really need to look into this. The second person who shocked me was Lee Sedol. That match with Google's AlphaGo. And the third factor was becoming minister and realizing we must also become a systems semiconductor powerhouse, moving beyond just memory chips. Our ministry's motto at the time was the great transformation to a digital economy. So I pushed that agenda until my term ended in 2021, and then I went to Harvard Kennedy School. When I got there that year, the weaponization of semiconductors was the hot topic. Forums were popping up everywhere, but neither the Korean government nor Korean companies were attending. I thought, this is strange. Taiwan is here in droves, and Japan is approaching this strategically. Why is this happening? At first, I complained to the Harvard Forum organizers. They said, well, you're here. Why don't you be a panelist? That's what they said. But if you join a panel, you have to dig even deeper. You have to study harder. I said, I don't think that's right. Later, after I got to know them better, I asked again, and they told me the truth. They said, your country, both the government and the big corporations, are too bureaucratic. First, they're hard to schedule. Second, to hold these seminars, you need sponsors, and
You're not coming, right?
they don't show up. So I realized this isn't good. This is serious. That's why I wrote the book. I wanted to sound a warning. South Korea is too drunk on memory semiconductors. We're just sipping champagne. The world is completely shifting to AI semiconductors, but our market share in system semiconductors is only 3%. That's not enough. I thought if we're not careful, we're going to lose to Taiwan. That was in 2023, and now we are losing to Taiwan. Both the ecosystem and the GDP starting this fall, Taiwan's GDP per capita is $38,000, while ours is $37,000. Taiwan's economic growth is 5%, ours is 0.8%. Next year, Taiwan's GDP will surpass $40,000. That means Taiwan will overtake us in GDP for the first time in 22 years. And the reason they are pulling ahead, it's AI semiconductors.
I've also bought and read a lot of semiconductor books to study up, but most of them are about the manufacturing process or memoirs from people who worked at Korean companies. This was really the first time I'd read a book written from such a global perspective without a technical background. I found it fascinating. CEO Kim, I assume you've read it. What did you think?
This book is actually the reason I'm here today, because there are a few books on AI semiconductors out now. There's Chip War, which sounded the alarm in recent years, saying, this is a strategic material, a strategic asset, and a strategic weapon, and we missed it. There's also a recent book by Lin Hongwen, Chip Island, How TSMC and Taiwan Triumph. So, if Korea currently has a national goal of becoming a top 3 AI superpower, we need someone who can offer proposals and advice on the blueprint and details for achieving that goal. As someone who isn't in the industry or a technical expert, she identified about 5 key points that she shouldn't have been able to know. Reading those parts, I thought, how did she know this? It made me realize that Minister Park is someone with an intense, pure curiosity who relentlessly investigates something once she sets her sights on it.
Oh, thank you.
Next time, people like you, Kim, should be the ones going to those Harvard panels and forums.
That's right. You should go.
The US is very nervous right now about falling behind China. That's why so many of these forums are happening.
We always tend to focus on the technology or on Silicon Valley in the West, but it seems we also need perspectives that see the bigger picture. Minister, I'd like to ask you about something you mentioned, the strategization or weaponization of semiconductors. From what you've seen and heard on the ground, could you explain the current global situation surrounding AI chips?
To put it simply, there is no AI without chips. You can't have AI without semiconductors. And there is no life without AI. In the future, our lives will be impossible without AI. That's the situation. Since World Wars I and II, if you asked what the most strategic asset was, the answer would have been the oil economy or oil money. But we are now in a transition where AI semiconductors are becoming that national strategic asset. Look at this past May when the US president visited Saudi Arabia and the UAE. In the past, the focus would have been on oil prices. This time, there was no talk of that. It was, we will give you X thousand AI semiconductor chips by, say, 2027, and in return, you will invest X amount in the US over the next 10 years. They signed deals for that. That was a very symbolic moment, showing that AI semiconductors are the national strategic asset of the future. Globally, if you look at AI infrastructure, dedicated AI computing centers, AI supercomputers, only 32 countries in the world have them. And 90% of the data centers and supercomputers operating in those 32 countries are run by the US and China. That means the other 150 plus countries have nothing. Eventually, these nations will have to choose, become dependent on the US or become dependent on China. So what if we become a top 3 AI superpower? Then our strategy needs to be, if you don't want the US or China, come to Korea. Furthermore, because of power supply issues, it won't be easy for those 150 plus countries to build data centers or supercomputers. This means that right now is a critical moment. Our national standing regarding AI and the future of the AI industry will all be decided within the next 3 years. For example, if you look at the 3 major stages of AI, first was perception AI, which recognizes things, text, images. Next came generative AI with the arrival of ChatGPT. ChatGPT arrived in November 2022. The next step is agentic AI, and agentic AI is where AI becomes industrialized. This is the period of industrialization where we must plant our flag.
In a way, the G2, US and China monopoly is becoming even stronger than it was in the oil era.
Exactly. For instance, the reason we could be an IT powerhouse for the last 20 years was because President Kim Dae-jung installed high-speed internet across the entire nation. We rode that wave. Back then, the competition between the US and China wasn't this fierce. In fact, China wasn't really in the game. It was much easier for us to become an IT leader. Now, the US and China are fighting for hegemony over the AI agenda, and we are lagging behind. So what we need is a sense of desperation. I think that's what's required.
As you said, in the US and China, corporations seem to be taking the lead. These companies are securing and buying massive amounts of AI chips to build hyperscale data centers. And that scene is dominated by NVIDIA. Big tech firms are also making their own chips. In this situation, I wonder if it's even enough for Korean companies to secure as many as they can. CEO Kim, what are your thoughts on that?
Let me explain a bit about AI semiconductors. You have the hyperscaler market, AWS, Google, Microsoft Azure, and so on. In my view, NVIDIA's dominance is solid for 3 reasons. Everyone knows about their software ecosystem CUDA, but one thing people don't often see is their connectivity technology, NVLink and InfiniBand. You can't process large-scale AI data with just one chip. You have to bundle multiple GPUs, and their communication latency is 7 times faster. It's an overwhelming gap. It's very difficult to overcome that in the short term. AWS is making its own chips. Google is famous for its TPU. Microsoft is making its own chips, and Chinese companies are too. There's hope that someday they won't need to use as many GPUs, and it does help them right now. It's not a negative. So various companies are trying to make their own. People say Broadcom is becoming a rival to NVIDIA. What Broadcom excels at, it was a communication chip company, is a technology called Tomahawk. They also say it's twice as fast as NVIDIA. Importantly, they've already ported this IP to TSMC's 2nm and 3nm processes. Hyperscalers who want to build this chip have no choice but to go to TSMC. Will hyperscalers get so good at making chips that they can one day operate without NVIDIA's GPUs? Will that day really come? I have a question mark there too. I don't think it will be easy. But they will probably be able to handle their own internal traffic, and since GPUs are so expensive, it'll likely be a business that doesn't lose money. But in the longer term, on the other hand, you have on-device AI semiconductors. This market will likely expand as physical AI advances. It's fine to have AI on a distant server, but there's a real need to put AI directly into wearable devices, cars and drones, and have it run without a network connection.
So are you saying it's difficult for Korean semiconductor companies to target the server-side AI accelerator market?
No, not necessarily. Personally, I believe our country has the economic power. We're a top 10 nation and we have accumulated significant research capabilities. NVIDIA's chips consume 100 watt, but there's no way to supply 100 watt to a device. Solutions that just shrink down a GPU still consume 100 watt or 50 watt. This is now the era of power efficiency. You need to be at 5 watt or less to be integrated into a device. I see this market starting to open up next year. Products based on-device AI. From that perspective, a first mover strategy is possible. It's a happier scenario for me because we can compete on a level playing field. There's no absolute ruler.
So in short, you're going to be the Jensen Huang of the Korean on-device semiconductor market. I'm cheering for that.
You saw the on-device AI semiconductor market clearly and entered it.
He has the insight.
Park, is there anything else you'd like to ask the Kim regarding on-device AI semiconductors?
After the era of agentic AI, we moved to physical AI. I believe that for physical AI, computation right there on the scene, at the edge, is crucial. Therefore, I predict the demand for on-device AI will increase. What do you think?
Physical AI and on-device AI are almost the same concept. In the past, to make a robot perform an action in a factory, brilliant researchers had to do massive amounts of coding. It was so difficult that automation stalled for decades. But now, when you input generative AI, it's capable of near-human intelligence. Recently, you can just demonstrate an action once and the robot copies it. The reason people think physical AI will be the biggest thing is that it can replace immense amounts of labor and lead us toward unmanned manufacturing. Seeing that potential, expectations for physical AI are rising dramatically.
Then you must need a wide variety of these chips, right? It's not like one single on-device AI chip can run a robot, a smartphone, and an autonomous car. A single company must have to make many different versions.
The reason I like the on-device market is that it is highly fragmented and requires massive customization. We've been saying we'll become the ruler of the shallow seas, and I recently brought up the Battle of Myeongnyang. When I looked at making AI semiconductors, if I were to target the server market, I saw that as difficult. It felt like being a single fishing boat in the middle of the Pacific, running into the US 7th Fleet and being told, win this fight. I thought, historically, there's another way. You lure the large fleet into shallow, fast-moving waters. Fast-moving waters means the customization demands are intense, and the market, for one segment, might only be $40 million, $80 million. There are dozens of segments like this. From our perspective, even a $40 million segment, if we can capture just 2 or 3 of those, it's incredibly meaningful. The second important thing is that this market will grow 10x, 100x in the future. Seeing this, I thought, I can do this. So when I look at making on-device AI chips, I feel I can take on AMD. They're a giant, but I can ask, are you really going to fight me in this shallow sea, in this 50 billion $1 tilde $38M market? I can strip out everything unnecessary and use 1/10 or 1/20th the power. Look at Admiral Yi Sun-sin during the Imjin War at the Battle of Myeongyang. 300 ships attacked, but he only had 13. If you are certain you can win a one-on-one fight, you just keep creating one-on-one scenarios. If I know I can win that 1v1, it's game on. So, we're fighting 1v1.
That seems like a very effective strategy for a Korean startup. On the flip side, I'm curious about the strategies the US and China are taking. Minister, could you share what you've observed?
For example, the US is transitioning from pride to perhaps arrogance in its belief that we are the home of AI. In July, the president signed 3 directives in an AI action plan. The first one is, we will become the global standard for AI. And all you pro-US nations, you will adopt this standard. Let's form an alliance, a package deal. We will lead the way in AI hegemony. That's the first. The second is, we will make it easy to build semiconductor plants and data centers. We will remove regulations. The third was about woke AI, which is a bit political. Essentially, progressive diversity concepts. AI must remain neutral. This is not allowed. While the US announced that on August 26th, China announced something different. An AI plus deepening policy, or as they call it, action deepening opinions. They had announced the AI plus policy in March 2024. The core of AI plus is, we will use AI integration as the new engine for China's economic growth. That's one pillar. The second pillar is, in response to US regulations on AI semiconductors, we will build a self-reliant ecosystem. Based on this, they released these action-deepening opinions. This document outlines a much more detailed roadmap. And it is massive. It states, by 2027, increase the adoption of intelligent systems to 70%, and by 2030 to 90%, internalizing AI across all industries. Then, by 2035, create a new system for an AI-based economy and society, a fully intelligent economic and social society. They released this precise roadmap and defined 6 major areas for AI integration. No other country has announced such a detailed AI policy.
Not even the US, you're saying?
For example, China's strategy is to find momentum in its domestic market through AI internalization, and then use that to engage in international trade. Their strategy is to capture markets where the US doesn't have reach, like South America, Africa, and Southeast Asia. The US strategy is more, we're the leaders in AI, so pro-US nations just follow us. That's why I honestly question whether the US can maintain its superiority over China when the age of physical AI arrives. Yes.
In China's case, they had the Made in China initiative, and a few years ago, the semiconductor rise. But I've also heard that the results, in some respects, haven't been very good.
They've been at this semiconductor rise, which Xi Jinping announced in 2015, for 10 years now. Their original goal for 2025 was 70% semiconductor self-sufficiency. In my view, they've reached about 40 to 50%.
Yes, Kim, what's your assessment?
I see it similarly, but with a few differences. I agree. The medium for this hegemony war is AI semiconductors. But beyond that, the goal neither side is talking about openly is, who will win unmanned manufacturing? When I piece together all the current shifts and movements, this is the picture that emerges. For example, the US is racing hard towards superintelligence. To get to unmanned manufacturing, step 1 for the US is secure superintelligence first. As for the rest, they don't have a manufacturing supply chain. The US spent decades turning China into the world's factory, losing all its own manufacturing assets in the process. Now they've realized they must rebuild that manufacturing SCM. That's why they are reshoring all these factories. It's not that these new factories will hire a lot of people, they are advanced factories. But that doesn't matter. The goal isn't to create more American jobs. The goal is to complete a self-contained block manufacturing industry inside the US. To do that, first, they need superintelligence. Second, since they lack immediate manufacturing capacity, they must reshore, which they are doing at an incredibly aggressive pace. That's the direction. They outsourced manufacturing because labor costs were high. But with unmanned manufacturing, labor cost is zero. Then there's no reason for the US to lack a competitive manufacturing capability. This seems to be their aim. As for China, recently Alibaba released an AI chip, which was an alarm bell, and Huawei released a 7-nanometer chip. Then in February this year, DeepSeek emerged, sending a message: we can make algorithms cheaply. These are warning signs. But technically, in my judgment, while US hyperscalers are also still developing their own chips, China's chips are just more of the same. They aren't on a path to completely replace NVIDIA's GPUs, but that's the message they want to send. And looking at DeepSeek, they used an MOE architecture in H20S. From a hardware perspective, they ran a small model, but the message was, the intelligence level is high. Just 3 months after that, Meta released Llama 4. It's 200 billion parameters. We can build a model this huge. The intelligence goes even higher. This actually helped the US side in the race for superintelligence. It's a game of tit for tat. So I still have a question mark as to whether China has the technology to be fully independent. But what scares me when I go to China is this. We met with Baidu in February, around the time DeepSeek came out, and we recently signed a contract. They are using our on-device chips in their application, and the model running on their servers is DeepSeek. They put it into mass production just 3 months after it was announced. This speed, not Korea, not Taiwan, not the US, no one can keep up with this speed. When it comes to implementation speed, applying it directly to applications, China is overwhelming. And what's scary is that by doing this, they accumulate know-how and data. AI grows on those two things. China is aggressively inserting this into its manufacturing sector. If that data and know-how keep accumulating, even without superintelligence or NVIDIA GPUs, they are implementing. Who will reach the finish line first? And the third question is, Korea must be in the top 3 in this race. If we are, we can become a first-tier nation. If we miss this race, it's a moment where you have to think, what is our future?
Right, the US might lead in technology, but from my perspective, it's about price competitiveness. Specifically, humanoid robots in the physical AI era. No country can make them as cheaply as China. If China pursues a mass adoption strategy, can the US withstand it? That's a key point.
I agree with that from an industry perspective. A robot made in the US costs tens of thousands of dollars. People see that price tag and say, who would use that? But if you buy one robot and have it work for 10 years, when you calculate the equivalent labor cost, it's not expensive at all. It suddenly becomes viable.
About 1 year's salary.
Right, it's like 1 year's salary, but it works 24 hours a day. It doesn't get tired. It can even swap its own batteries. But when I promote our chips in China, I meet robotics companies like Unitree. I was shocked recently when they said they were making a robot for about $15,000. $15,000? But right now their market goal is to build a humanoid for $5,000. And the scale is different. The initial order volume is 100,000 units from one company in China. There are about 20 companies in the lead group, and one company is making 100,000 units. The initial PO is 100,000. They expect this to exceed 1 million units.
The manufacturing experience and the speed at which data accumulates, it's a completely different dimension.
Exactly. China used price competitiveness to push into the drone market, and they completely dominated it. What worries me is that China will use that same pricing strategy for robots. If you go to university labs in Korea, they're all Chinese robots. They're all experimenting using these robots that cost about $23,000. That part worries me a lot. Yes.
That's why I've been talking with the Hyundai Motor Robotics Lab for 3 years, and now our chip is in 2 products scheduled for mass production next year. For POSCO, we're in their factory automation in Vietnam and moving into other projects. This is what I tell these lab directors. If we can't pull this off domestically, China is on a different scale. We have to be able to win even in the low-cost segment. So when we talk leader to leader, we say, we have to work incredibly hard for our country's industry, for our future industry. We feel that level of crisis.